handicap. It should say lame. How do you get it to not say mute? How can you tell whether it's muted?
It would say mute.
It says mute. Can you hear me now? All right. Well, jolly nice. So this building has one of the coolest elevators. In fact, two of the coolest elevators I've ever seen. I recommend when you're going down to the barbecue, you take the stairs because it's healthy for you. Well, okay, take the elevator, but look up. Anyway, Dave Jaffe, in addition to being the webmeister and moderating my excesses, he also manages the exciting Who's Who. So he's going to tell you a few words about that.
Everybody is somebody, okay? And we want to know about you. So there's a web page on the FIG website that allows us to post, who you are and your relationship to Forth on there. And on the back of your agenda is the instructions for filling that out. So if you care to, and it's completely optional, and I understand about your privacy, and so that's okay. But if you want to, please put in as much information as you want and hand this to me at the end of the day, or email it to me, or fax it to me, and I will put it up there. And if you can send me a photo, then we can associate the photo of you with the description. And if you don't have a photograph, we can take one of you. So that's all I have to say. What are you pointing to?
Guy up front. Is that Jason?
Yeah.
Yeah, you took my picture. Yeah, he's got my picture.
Okay, I've got your picture too. Thank you.
God only knows. Nash, for those of you who've been here before, to Fourth Day or to our other sessions, you've seen this guy, and otherwise, I don't know what to say about him. I'm hoping that the microphone isn't muted, because we wouldn't want to miss this. Yeah, clip it to your collar, clip it to your belt.
Okay, how's front loaded here? If I can figure out how to work the clip.
So, Attorney General said no battle plan or survivor contact with the enemy. He phrased it differently, but that's the gestalt. And so, after I had done the schedule, and we had pretty much settled on it, Dave printed it, and then changes arrived. So there's some changes in the afternoon that we'll tell you about shortly.
Okay, I'm in the business mostly of trying to integrate hardware and software for a number of little small instruments that I do for hobby, and some I do commercially, and some I do just for other people, but for their hobbies. And recently, and I've noticed that most Forth programmers probably would just as soon the hardware didn't exist. Whenever they get to the point of having to produce hardware of some sort, and I'm talking about not just boards that you buy, but integrating hardware and getting cases and power supplies and getting components mounted and producing a prototype or to work or a working development system to a final product. And I've been involved in having to produce something that looks pretty nice to deliver to a client, to doing small prototypes and getting it working and handing it over to other people. And I just thought I'd share my experiences in producing hardware that can look very professional and complete, down to just generating working prototypes. And also the problem of if you're just doing it for a hobby, sometimes you're worried about expense. See, and sometimes you're worried about just getting up and running fast to show to somebody. And all of these problems can be simplified with various tools that are free and various products that are inexpensive, and I would like to show you one set of alternatives that may be of use to you. The first thing I would like to talk about is a tool stick. Now, I don't know how many of you may be familiar with it, but if you aren't familiar with it, this little thing on the end of the wire here is a tool stick. And what it is, it's a development system sold by Silicon Laboratories that produces 8051 compatible instruction set chips that'll run at anywhere from 25 to 100 megahertz and have 128K down to several K of program memory, one-time programables, USB interface chips, a wide range of processors and specialized hardware that you can use to develop products. These aren't particularly popular, and I don't know why. The company is very substantial. They have a wide range of products, and these products are used in automobiles and everything else. So I think the company, it has been around for a while, and I think it will be around for a while. So the tool stick, this little guy right here, is a tool stick 362, and I'm just going to use this as an example. This provides a total of 25 I/O ports. They're all available on 10th-inch centers. So if you install stake pins on this thing, you can plug it into a motherboard, which is an assembled version is here. You can see these up close later on after the presentation. And here's a little board that I designed. I'll tell you about how I designed the board later, but this is a motherboard. And you can see the 10th-inch centers where the tool stick mounts, and here's where a connector mounts, and this is how you get out to your real hardware. It's just a ribbon cable and a connector, and you can go out to things such as an incremental encoder with a push-button switch. Costs under $1. Okay? Inexpensive user interface, or an LCD display, $7. So for $8, you can get a user interface, and I'll talk about that a little later too. But getting back to the tool stick and the motherboard, this is an example of a motherboard, but you can take this thing and glue it down on a piece of perf board. You have to install the stake pins. It doesn't come with the stake pins soldered in, but that's fairly easy to do. And you can throw this thing down on a perf board and start wiring to it and get your hardware up and running. What kind of features does it have? Well, I have a number of copies, I think maybe about 20 copies of the presentation in a slightly different format. But this tells all the details of the tool stick. And but one of the things that it includes is an example of what the 362 processor is. An example, this is a 362 tool stick, but they have tool sticks for almost all of their processors. And these tool sticks, you notice that they have a little card edge here, and that fits on a programmer. $18, available from Mouser and DigiKey. These are available for $10.25 from Mouser and DigiKey. Okay? Very inexpensive and easy to develop. And this is actually the finished application. This thing looks a little funky now, but it plugs into this motherboard. Here's the increment, the display, and here's the incremental encoder, and then this goes out to BNC jacks and power jacks, and this is the interactive RS-232, it's an RS-232 jack to go to the level converters, and I use it interactively with my fourth. But anyway, the typical, I said 25 I/O pins, 3 I/O ports and an extra, and a reset switch and stuff is brought, and power regulated. This tool stick includes a power indicator, LED, test LED, an analog input pot, if you want to play with that, a 3.3 volt regulator, and the whole thing is powered by USB through the interface port. So all you do is you plug the daughter board, the programmer, into a USB port, plug this in, and use the free tools for IDE tools from Silicon Laboratories to download an Intel hex file. My fourth produces Intel hex files for the 8051, and I don't know if SwiftForth does too, but probably could be. Yeah. So of course, I use my fourth, which is, there's 2 other programmers in the world that use it, but anything that can generate an Intel hex file for an 8051 could be used. They have an assembler, they have a C compiler, and so on. C compiler is very, very limited. The assembler is pretty much full-featured, but you have to get a key code and install it. It's a little involved. But if you have fourth, you generally can program these things relatively easily. But to give you an idea here, and I know I'm probably running out of time here, but these...
minutes.
Huh?
Easily 15 minutes.
Okay, good.
Time's over here.
100 MIPS 8051. So 10 nanoseconds is pretty peppy, for an instruction. Most of the instructions are optimized for single cycle operation. There's a few that take quite a few more. That's one of the caveats I have. But it does have another caveat. It has a 2-cycle 16 by 6 multiply accumulate. But as Charlie Shattuck pointed out, you have to get the stuff into the registers before you can do it and get them back out. So it's not quite a 2-cycle Mac, but at least you can do a 16 by 6 Mac. This particular one has a 10-bit current output DAC, which only a single one that can be assigned to almost any port, or to a couple of ports. 10-bit A to D converters, and you can assign them all A to D converters to all the ports if you want to. And have a crossbar switch, very nice technology where they can attach almost any peripheral to any port pin. Very flexible. Has 1280 bytes of internal data RAM that is mapped as external RAM, 8051 external RAM. So you use the MOVEX instruction, but it's actually internal to the chip itself, not external. You can attach external memory also. I've never used that. I've used it once. This particular chip has 32K of memory. But you can get other ones depending upon the price, performance, and stuff. Almost all of my the biggest application I've done is 8K. So I don't, except for some that took data memory when I was streaming out waveforms and stuff. But the inputs are all 5-volt tolerant. The outputs will source or sync around 15 mils. So you can drive LEDs directly and use them as buffered outputs and stuff. Some of the really nice features of these, almost all of them have internal comparators. And a recent project just was a couple of protection diodes and scaling resistors. I went directly into the comparator port with a 10 millivolt peak-to-peak signal, and I generated my square wave that I needed to drive things. The output of the comparator is available as a bit that's set in software, or you can write it to route it to an output pin. You can route the sysclock or sysclock divided by any number of binary numbers out to a port pin or not. And you can also, they have some 16-bit timer counters. They have three timers, and with interrupts and the general stuff you use for serial ports and all that. But one of the nice things, they have capture compare registers. So if you get a 16-bit capture compare register, so you can take a divided version of the clock or the clock itself, and when you hit a compare, it will generate a toggle or an output, or you can execute code, check bits, things like that. And they have 3 of those in most of the chips. And they're quite useful. So and this is all independent of the software. Once you set these things up and route the outputs to a port pin, the hardware just generates whatever clock. And I'm using this to replace a divider chain built with discrete chips. You can get at least 3 and outputs that are completely independent of the software. So then you go do your software after you get this stuff set up. It will operate at 24.5 megahertz software tunable internal clock. You can have an external clock with a crystal and a couple of capacitors. You can generate it with an external clock or feed it with an external clock. And it's pretty low power, and you can also have resistor RC clocks if you're going very low cost. Wide variety of packaging, and the packaging on this one is a little tiny melt package. You can see there's the processor there, which I hate to deal with, but it's all mounted on a system board for you, so you don't have to deal with it. But if you have to do a custom board, there's a wide variety of packages, and down to the one-time programmables, which are 80 cents each, costs you $120. That includes the programmer's socket for a SOIC chip, and you get one-time programmables for 80 cents each. And those have 4K of internal memory and one I/O port, but they have all the other features, the comparator, the capture compare registers, the clock, all that kind of stuff. So SOICs aren't too difficult to deal with on circuit boards. I have, for all of the things, the key things that I mentioned, there's a parts list that show you incremental encoder, the display, where to get them, the part numbers, things like that, and CPU modules. Well, I'd like to digress a little bit to, here's an example of Silicon Laboratories also produces these development boards. Now these range from $35 to $50. Most of them are $35, these blue boards, this part. And you can see they have a sea of holes, breadboard area, usually with a connector next to it that brings out all the I/O. Well, you can make custom PC boards or use perf board and glom right onto them and put your custom circuitry on there. This one has a direct digital synthesizer chip on a little carrier board. This is all made with perf board. Here's the incremental encoder, and the LCD just plugs in right there. So you've got your user interface. This whole thing you can pull it off in your next project and put another one on and use the same processor chip. And here's an example of a project I did, commercial project, that used, I made a PC board as a daughter board that fits right on one of their development kit boards. This was $35. This is for, I believe, a 310 or a 410 chip, I can't remember. And so, you say, how do you make these daughter boards, you may ask. Well, you can use them, Express PCB. It's what I've been using. There's other ones out there I've heard are just as good, but Express PCB, and I've got the link in there, can produce silkscreen, solder masked, very commercial quality boards. You can come up and take a look, and I'm very, very happy with them. They'll turn it around in 3 days. This board costs $91 for 3 of the standard size boards, which are 2.5 by 4, something like that. You can make multiple, put multiple boards on one blank with this. Here's the output of Express PCB. It's all manual layout. You say, well, why not use a package such as Eagle or something like that? Turn it in. Well, I love Eagle. I've got Eagle. I've got the commercial version of Eagle. But the free version of Eagle will produce very nice schematics. This is what I use to document my projects. But for the density of boards, generally most of the equipment that you need is right on these boards already. Like say the regulator and indicators, test switches, things like that are all on that board. So you don't need a lot of glue for a wide range of projects. And you just manually lay this out. It's a little tedious, but it beats hand wiring point to point. And it costs money. But if you're just prototyping, you can see there's a whole wide range of boards that I've done here. There's my bag of boards. You can come up and look at it. And these are no silkscreen or solder mask, but it is plated through and gives a pretty good result. I wish I would have known about the silkscreen solder mask before I produced this as the core module for a commercial project I did, but I didn't at that time, and that's part of the reason I'm presenting this. And we interface to a wide variety. I've got code in my forth if anybody's interested. This is an aside. To drive things such as an Ethernet module here, less than $20 for this plug-in module here. So if you need your micro to talk to Ethernet, I've got some sort of sample code. It wasn't all that obvious. I didn't develop it, Bill Kibler did. But one of the things here's the standard board that they produce for their top-of-the-line processor, which is a 120 processor. It's got, what, 128K, I think, or something, a lot of memory, and, you know, the 100 megahertz and all the other features. But I've got standard board templates to interface to this. If anybody's interested, just contact me. And then the module just plugs right on there, and voila, you have an Ethernet interface to your board. Now, the 120, you don't need the higher performance board to interface to this. There's versions of this you can interface SPI. This was interfaced through a single 8-bit I/O port. Well, with some control lines and stuff, but a handful of I/O. And the last thing I want to mention is, well, okay, fine. You've got a little assembly. I don't know whether you can come up and look at this later. It's not too obvious. But here's a board assembly for a project that I'm writing up for a magazine article. And this assembly has the tool stick. It has my little motherboard, and which is actually smaller than the daughter board. And the $7 LCD display and the incremental encoder, and some very nice LEDs, by the way, which are also on the parts list if you're interested. But that's in a vertical format for the board stack. And this is a horizontal format. I won't put this thing back together because I want people to be able to see it. But essentially you can have it set up like this with the board down below, and then this plugs into the bottom there, depending upon whether you're vertically or horizontally challenged in your project. So you got it all together, and you've got your wiring figured out, and you got your boards all made together and developed and so on. But now you finally want to deliver your project to somebody that might care if it looks sort of homebrew. And use Front Panel Express is what I've been using. There's several other ones that I hear are just as nice. And you can produce a panel like this for, I'm not quite sure, I did a 2U rack panel for $50, 3 of them for $50. So on the order of $30 to $50. And it's about 5 days delivery, but they have free.
What the aluminum costs, they throw the machining for free, pretty much.
Yeah. Well, what they do is they have free software you download, and you do the panel layout. And they have templates, of course, for rack panels and standard size holes for BNCs and things like that. One of the nice things, though, about it is that if you're doing some home and you're cutting out your own panels, you can print out full-size templates that have little crosshairs in there, and you can use that for a punch template, or hole punch and drilling and punching template for your own stuff. Or you can send it off and have them fabricated. And they do have a pull down that tells you how much it costs for engraving and coloring and panel thickness. You can get almost anything, steel or aluminum, whatever, almost any finish you want, natural finish or black or almost any color you want. Pardon me?
Does that include anodizing?
Yes, yes, and almost any color you want. And one of the things I did is for this project that I showed you here, is I just bought a standard Hammond rack cabinet, which is on the parts list there, $60 or so, but you know, they were paying for it. And I made a template so that for the front and for the panels, I removed the standard panels when I got the Hammond cabinet, and I took the finished, I took the panels that I had designed and screwed them right on, and it looked like a custom enclosure. So and the Front Panel Express reference is also in the paper. And I'm not, well, questions?
Could you email me a copy of your paper so that we can get it on the website with the fourth day notes?
I certainly can.
Cool.
Okay.
Because somebody might watch the video and say, well, where the hell is this thing?
Yeah, right. Well, okay. And, one of the things here, this particular project, here's the incremental encoder. We put this on a wing because it was a VFO application, or one of the things it does is a variable frequency oscillator for a ham thing using a direct digital synthesizer chip. But here's a fairly complex board done with Express PCB without the silkscreen and solder mask. It gives you an idea. You can do some fairly complex stuff with hand layout. And I say at 3 boards this size here. I'll show you their standard board size. Well, this is a standard board here. Forget Sol's connector, but there's the standard board size. And you saw that I was able to get 4 per board, and you get 3 boards this size for the delivered to your doorstep in California with all of the sales tax, non-tax nonsense and everything is, I believe, is $61 or something. If you get silkscreen and solder mask, which is the Pro option, which is mentioned in there, that's $90 delivered to your doorstep. Not too bad. So for this little board right here, after cutting out all of the boards and everything, it came out to be $7.50 with tax and all that kind of stuff, which I've also got the templates for all of these. If anybody's interested, you can ask me, and you need to produce things that are similar to this, like a tool stick motherboard. This includes all of the input signal conditioning, driver transistors, a couple drivers, some diode arrays for clipping the input signals and making it a little bit more commercial rather than just something that I'm testing locally. And here's a different project. And the last thing I'd like to talk about is the menuing system using this incremental encoder and the 8-character LCD. I just scroll, you turn this knob, and it scrolls the options by including a back arrow option for if you're nesting down levels. But you scroll the option by, you see the one you want, and you hit the button. If you need to set values or something, then you can set the values with this. And I've set times and set delays and various things like that. And then if you have a main menu, and I use the cursor, a blinking block cursor to show you're on the main menu, you go to one of those sub-menus, and then of course it gives you a back arrow option so you can go back up. And you just scroll, and I've gone down 3 levels, but there's really no limits, but I like to limit them to 3. And very, very functional user interface. Ta-da! Yeah. And see if I can get out of the way before the next